All right, guys. So last section we're going to do for now in chapter 7 with scientific notation. So previously you used laws of exponents to find products and quotients of monomials. Now we're going to express numbers in scientific notation and find products and quotients of numbers expressed in scientific notation. So that's the vocabulary from last section. This time we're going to talk just about scientific notation. So space tourism is a multi-billion-dollar industry. For a price of $20 million, a civilian can travel on a rocket or shuttle and visit the International Space Station for a week. $20 million. Wow. Very large and very small numbers, such as $20 million, can be cumbersome to use in calculations. For this reason, numbers are often expressed in what's called scientific notation. A number written in scientific notation is of the form some number a times 10 to the nth power, where a is a number greater than or equal to 1, but less than 10. So it can be any decimal between 1 and up to, but not including 10. Okay? So it'd be like 9.9999999, but once you hit 10, you're no longer technically in scientific notation. And n is an integer, so the exponent has to be an integer, positive or negative number. Okay, so here's the key concept for scientific notation. Move the decimal point until it is to the right of the first non-zero digit. The result is a real number a. Note the number of places n is the number of places and the direction that you moved the decimal point. If the decimal point is moved to the left, write the number as a times 10 to the n. If the decimal point is moved to the right, write the number as a times 10 to the negative n. So if you move it to the left, you get a positive exponent on 10. If you move it to the right, you get a negative exponent on 10. Remove any unnecessary zeros. All right, so let's express 21 or 201 million in scientific notation. Well, you have to move the decimal point. It's understood to be at the end of the number, right there. So you actually have to move it 1, 2, 3, 4, 5, 6, 7, 8 places to get one non-zero digit in front of the decimal point. Okay? The decimal point is moved 8 places to the left, so n equals 8. And 201 million can be written as 2.01 times 10 to the 8th. And you can remove all these zeros after the 1 and just write it as 2.01 times 10 to the 8th. How about this one, 0.000051? Well, this time we're going to have to move the decimal point to the right 5 places. So that means that n equals 5, but since I moved it to the right, I'm going to use a negative in my exponent. So it's going to be 0.00 or 0.00 point, keep messing that up, 0.0005.1 times 10 to the negative 5th. Okay, remove my unnecessary zeros, and I get 5.1 times 10 to the negative 5th. All right? So remember, however many places you move it to the left is the positive exponent. If you move it to the right, it's a negative exponent on 10. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So this one, I'd have to move 3, 6, 9, 10 places, so I get 6.870000 times 10 to the, what did I say? 3, 6, 9, 10 power. I can remove the unnecessary zeros, so 6.87 times 10 to the 10th. All right. This one, you'd have to move 1, 2, 3, 4, 5 places to the right. So it's going to be it's going to be 0.725 times 10 to the negative 5th power. Remove my unnecessary zeros, 7.25 times 10 to the negative 5th power. Okie dokie. Alrighty. So you can also rewrite numbers in scientific notation in standard form. So now this is going from already in scientific notation back to standard form. So in a times 10 to the n, note whether the n is positive or negative. If n is positive, move the decimal point n places to the right. And if n is negative, move the decimal point n places to the left. Insert zeros, decimal point, and commas as needed for place value. Okay, so basically you're just reversing what you did. So I like to think that the exponent, if it's positive, makes the number bigger, so you move the decimal to the right. If the exponent's negative, it makes the number smaller, so you move the decimal to the left. So 6.32 times 10 to the ninth, I'd have to move the decimal 9 places to the right. So to do that, you have to supply extra zeros. Now, you don't automatically just put 9 zeros on it. Don't do that, because the first 2 places that you moved are taken up by the 3 and the 2. So in this case, you'd have to put 7 more zeros. All right? So it's 6,320,000,000 is how you would write that. Okay, so 4 times 10 to the negative 7. I like this one because there's no decimal written in the problem. Well, remember, if there's no decimal, it's understood to be at the end of the number. So it's like 4 point times 10 to the negative 7. So you have to move the decimal 7 places to the left because the exponent is negative 7. So you start at the 4 and move 7 places to the left. Okay, so the 4 counts your first place, and then you keep going from there. Okay, so it's 0.0000004. It makes the number a lot smaller. All right, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So if I have 3.201 times 10 to the 6th, I start where the decimal is, and I have to move it 3 or 6 places to the right. So the first 3 places are going to be taken up by the 2, 0, and the 1, and then I have to do 3 more. So I have to supply the zeros. And put in the commas. Let me make that not look like a 6. So it's 3,201,000. This one, I have to move 5 places to the left. So 1 place is taken up by the 9. So 2, 3, 4, 5. Then that's where I'd put the decimal. Supply my zeros. So it's going to be, you could put a 0 in front of the decimal if you want, but that doesn't count as one of your places that you move. So it's 0.000903. All right. All right, guys, that's it for this first half of the section. Please stay tuned for the next one. See you there.